A man and his daughter manufacture unfinished tables and chairs. We're going to let X represent the tables, Y represent the chairs. Each table requires 1 hour of sawing and 3 hours of assembly. Each chair requires 2 hours of sawing and 2 hours of assembly. So for each of the tables and the chairs, we have a time for sawing and a time for assembling. So going back to read those sentences again, each table requires 1 hour of sawing and 3 hours of assembling. So for X tables, we'd have X hours of sawing and 3X hours of assembling. For each chair, we would have 2Y hours of sawing and 2Y hours of assembling. Now continuing, between the two of them, they can put in up to 8 hours of sawing and 12 hours of assembly work each day. Find a system of inequalities that describes all possible combinations of tables and chairs that they can make daily and graph the solution set. So now we have the fact that the sawing is constrained. They can only put in up to 8 hours sawing per day. So 1x plus 2y has to be less than or equal to 8. And they can only put in 12 hours of assembly work, so 3x plus 2y has to be less than or equal to 12. Now I'd like to isolate the y in each of these cases. So we get 2y is less than or equal to the opposite of x plus 8, or y is less than minus 1/2 x plus 4, and 2y is less than or equal to minus 3x plus 12, or y is less than or equal to negative 3/2 x plus 6. So now we're going to graph the system here. And first of all, choose the line tool. And within the line tool, we're going to choose 2 points. On the line y equals negative 1/2 x plus 4. And so we'll let x equals 0, y equal 4, since that's the y-intercept on this line. And then we'll notice that if x is equal to 8, y would equal 4. I'm sorry, if x was equal to 8, y would equal 0. And so there's one line, and it is less than or equal to, I'll just pull that down a little. I'm sorry, I should have had less than or equal to in that condition there. So we will be leaving the line as a solid line, and it's less than so it's everything on or below. In the second situation, again, I'll choose the line tool, and I'll start with the point 0.06. The y-intercept. And note that if x was equal to 4, y would equal 0. So 4, 0 is another point on that line. And that's parts of that line are also going to be on the boundary because of the less than or equal to. So we're looking for a region that is below both of these lines. So when I go to the fill, I will choose this region. This time we were not asked to find the vertices, just the region. And I'm going to have two more restrictions because although I thought that the WebAssign had restricted us to the first quadrant, I see that's not true. So we should also have x greater than 0 and y greater than 0. And so let's go in and pick 0, 0, and 0, 10, and 0, 0, and 10, 0. And the fill now is entirely in the first quadrant, as it must be, because the tables and chairs need to be positive numbers.